Hey, AP Chemsters, this is Mrs. Vanderwall bringing you probably one of the first editions of what we call the Blank Wall series. Blank Walls are our version of video notes that you can use and you can follow along on your computers, and you can be taking your notes as you do so. A couple advantages of using these blank walls that if you ever need to pause and write something down, you can, and I encourage you to do so. You can add to your own notes from my explanations that you can always rewind if you didn't get something the first time. A couple of ground rules before we truly begin. Make sure that you do follow along. Make sure that you are thinking. Make sure that you are focused on what's going on. If you have any questions, I know that you can't just raise your hand and I'll answer you right away, but jot something down in the margins and you can ask me the next day. If you need to look something up, you can certainly do that. So I highly recommend that you actually do all the problems on your own. Just don't write down what I do when we come to some problems later on. And this should work out well. Something else to consider is that many colleges are going into the flipped classroom mode and model. So it is to your advantage to truly take advantage of how to take these notes. So good luck. I hope you enjoy these as I follow along here. So we are in section 1.4, chemical and physical changes and properties. And let's go and talk about a physical change. We saw a physical change at some point, probably maybe in your first year of chemistry. You probably saw a lot of physical changes. One that comes to mind right away would be, let's say, would be, oh, I don't know, evaporation. Let's go to that. And evaporation, of course, is when a gas is created from a liquid. And another one we could always use is that if a liquid is going into a gas for evaporation, well, can't a liquid also be made from a solid? And we call that melting. And folks, there are actually 6 different phases. We can talk about condensation, where gases become liquids. We can talk about, um, you know, making a solid. So you can go from a liquid to a solid. It's called freezing. And I think I'm missing some, but you get the idea. So whenever you have what I would call a change of state, you would have a physical change. Why is that? It is still water. It's water in a liquid phase. It's water in a solid state called ice. It's water in a gaseous state called steam. So it is still H2O. It has not changed its identity. Something else I'm thinking of is if you just want to take a blob of gold and you can hammer it into sheets. You are just flattening it out. You are not changing the gold atoms. You're just making thinner layers, thinner sections of that gold. So you are still keeping its identity. Another very important idea for other metals are drying it into a wire. So you can take this blob of gold and you can force it, extrude it into a wire. You are still keeping it as gold. One other thing that I am thinking of would be mixing. I got to be careful. I'm not reacting. I'm just mixing like salt and pepper or sugar and cinnamon. Yum, yum. Things like that. You are still retaining the salt. You are still retaining the sugar. They're just change their locale. That would be a physical change. So number 2 says draw a molecular representation of water boiling. Well, here's my initial picture of water as a liquid. Notice I have my oxygens are the red and my hydrogens are the yellow. And notice the proximity of these water molecules. They're quite close together. And that would be true of a liquid state. Um, a unique feature about water is that actually its solid state is further apart than the liquid state. That's why the density of ice is less than that of water. That's why ice floats. But anyway, why don't you go ahead and pause this and you show me what water boiling would look like. How is that a physical change? So go ahead and pause this, draw it, and come right back. Hey, how'd you do? Well, I'm just going to put this guy over here and this guy over here and this one way over here. And maybe this one is so far off the sheet. Okay, so that would be my example of water boiling. Have I changed the identity of the H2O? No, each one of those 4 are still H2Os. What did I do? Like I said with mixing, I just changed its locale. They are now further apart from each other. That's all that happens. That's a physical change. So what about a chemical change? Obviously, if a physical one is that do not change their identity, what do you think a chemical change is? One that does change its composition. So let me scroll down here. So chemical changes, some examples that I think of, well, immediately I think of anything that's burning. We know how much chemists like to blow things up. So if I'm burning a piece of paper, am I changing that composition of that paper? Well, certainly it starts off as nice and white and whatever, and it ends up as ash. I've changed its composition. How about another one? Let's talk about maybe rusting. Rusting is, you know, what iron looks like, very shiny, very silvery, and rust is not shiny, not silvery. It's kind of a reddish brownish thing, and it's very brittle. So you have changed its composition. Um, I'm thinking of digesting. There is something for you to think about. All right. So you go ahead and you eat your food, and well, we can probably talk about the fact that it doesn't, you know, come out the same, does it? That's kind of like a biology thing, though. But anyway, you have changed the identity of that apple or of that chocolate bar or something. And really, what is happening, if you ever see the word react, that's what they all are doing. They are all reacting. And so reacting is the same thing as saying a chemical change has occurred. So look at number 2 here. Draw the molecular representation of iron rusting. Well, I don't know if you can tell. This is my iron. And what must be present for iron to rust is, you got it, oxygen gas right here. So here's my oxygen gas. Typically, in a molecular sense, the oxygen is usually a red molecule. Carbon is black, hydrogen is yellow. So I try to keep that same notation for me. So what happens when you have iron rusting? So you're going to break this iron apart, and you're going to actually have some of these oxygens, in a sense, reattach. But that's not the whole picture. I actually need another iron and another oxygen. So that would be your rust in a sense, okay? Probably doesn't look exactly like that, but for right now, that's gonna be good enough. So look at that. How would you write that formula? Did you say Fe2O3? You're right. So that is one oxygen. So wait a minute. So I think I need some more iron. And I'm going to break apart this oxygen. And I have another oxygen and another iron and another oxygen. So I end up with two Fe2O3 molecules from what I started out with. So using our two representations, compare and contrast physical changes. So how could you talk about physical change? Think about what, you know, melting and evaporation and mixing. What's happening here? You're having just a physical rearrangement. You are changing its locale. And perhaps a better way to think about it is chemical. What happened when I moved here? What did I have to do first? I had to break bonds. And then what did I have to do? I had to form new bonds. That's your new identity. These new bonds that have formed, they have different properties. You know, they are totally new substances. If you think about iron, if you think about oxygen, you think about rust, you have a brand new substance. So physical, again, is just rearranging them. Maybe you're flattening them for the hammering them out in the sheets. Maybe you're just making them into a wire, or just, you know, spraying them apart. That's a physical change. Chemical, you're breaking bonds. All right, so let's see what's up next. So closely related to these changes, these physical and chemical changes, are just properties. A physical property is a substance that displays without changing its composition. So what does that exactly mean? It means that you can determine its physical property without changing its identity. So they sometimes go along with those changes that we talked about. So when we talk about melting earlier, we can talk about its melting point. So every piece of pure water, or, you know, pure ice, has the exact same melting point. You can measure it. Have you destroyed the water in the process? No, it's still H2O when it went from a solid to a liquid. How about another one? Let's talk about maybe density. Density is a physical property because you can measure its mass and you can measure its volume, and it still retains its identity. If you just want to look at its color, that would be a physical property. Just looking at it will not change its composition, and texture as well. And there are many, many other ones as well. Those are probably more common ones that you might be thinking of as well. And be sure, if you come up with other things than what I talk about and you want to mention them in class tomorrow, by all means, we can discuss this. Typically, we'll have a debriefing time after one of these blank wall sessions. What about chemical properties? It's a property that a substance displays only by what? by changing it. You only know if it's a chemical property if you've changed it. You don't have the original substance back. So notice a couple things here. Here's a chemical property, the ability to react with oxygen. How do you know that iron reacts with oxygen? Is by reacting it with oxygen. If it does, it's a chemical property. If it doesn't, then it'll be a physical. So, or I shouldn't say maybe physical, but it's still a chemical property if it didn't react with oxygen. How do you know? You're going to change its composition. How about another one? The ability to react with acids or bases. Again, how do you know if it reacts with acids? By trying it out. And if it does, you're going to change its composition. And so notice you have some key phrases in here, and it's the ability to react with anything. So if it reacts, it's a chemical property. Okay, so I think that's it for this page. Let's see what's next. Okay, what I would like you to do is look at this process or describe the process and determine whether it's physical or chemical. So take a minute out and look at these pictures and tell me what's truly going on. I would say this is an iceberg in water. I think this is maybe like sugar put in water, and this is a propane tank that's being burned. So go ahead and fill that out, pause this, and when you are done, come back. All right, how'd you do? Well, I think if you could look at the iceberg, that typically icebergs are going to melt. That is a physical change. How do I know? Here's my water. Remember what I told you about water? Water is very unique where its liquid state is actually closer together than its solid state. So there you go there. So we have the water molecule. Actually, you know what? I don't think that's water. I think that's actually carbon dioxide looking at its representation. That might be dry ice. So here's the solid form, here's its gaseous form, and again, that's a physical change. Sorry about that. My clue is that there's black atoms in here, which are usually your carbons, and your reds are your oxygens. So, all right, sorry about that, it's dry ice. I think I was better off over here. Here you have plain old sugar in a spoon. Here you have sugar and water. What's going on? You're mixing it. Has any bonds been broken? Not at all. If you look, the same picture right here is the same picture here. What's only different? It's arranged differently. All right, you have these all close together. Here they're separated by water molecules. So this is a physical change, and you're just, dissolving to the sugar. Over here, I definitely think that this is a chemical change. You're burning. If it's propane, typically that's what you burn. And if you look what's happening here, these are your propane molecules. And notice there are no propane molecules up here. They're totally different. You broke bonds and you form new ones. That would be a chemical change. What I would like you to do now is go ahead and finish this page for me. And so tomorrow, when in class, we'll go over it. Let's see here. Yes, so do that for me, and this will begin the next blank wall. So thanks a lot.